Okay. No, unless you guys want the lights off. Doesn't matter to me. All right, so we'll give ourselves a quick, oops, hold on. Exterior wall. How do I get, oh, do I have to use the laptop keyboard? That's why. I'm typing in your password over here. Okay, that makes more sense.
And the mouse next to it.
Okay. I know. All right, so I'll go ahead and do an 8-foot by 24-foot tiny house to help orient the direction if somebody's doing driver's side or passenger side. Tiny houses will typically have a 4-foot tongue, so we can just come out 4 feet, give ourselves that reference. F8 to go ahead and unlock the access, and then I can do MI. Oops. I can do mirror this line over here. Grab that. So we now have a base point. We'll grab this exterior wall and we'll place the frame. I'll go ahead and hit F8 again, lock that access. I'm drawing it to that side. And then I'll go ahead and clean this up in a second and show you guys why we orient the panels the way that we do. So what we'll typically do is have the tongue and rear of the trailer oversail the front from a wind resistance and holding up that interior wall so that, oops, holding against the, we want the front of the trailer, the one that's going to be seeing 70 miles an hour of wind, to be housing that wall that runs the 24-foot length, so that way you're not relying on the fastener connection to withhold that, you're relying on the entire connection itself. So we'll go ahead and just bring these back out. If you're designing in Rhino or if I'm designing in SketchUp, then I'll often draw the wall profiles myself as I'm going. The other thing that I do really quickly is I'll create references for myself. So a tiny house is 24 inches off the ground. That means you can have roughly a 10-foot 6-inch tall wall. We're at 8 feet, and then we'll go ahead on this tiny house, do a 9-foot short wall. I'll offset this by 3 5/8 of an inch. I could draw myself a roof profile there. Do we want overhang or no overhang?
Yes.
Overhang? So we'll offset this 6 inches on both sides. I can go ahead and, oops, grab this wall here. I'll trim extend this to that side, and then this one to this side. Go ahead and delete that. Offset 3 5/8. And then I have, actually we're going to go true 6. We're going to pull this one back, and we'll offset 3 5/8 here. The reason I'm doing this, and or if you have architectural drawings to trace all of this off of, it gives me the ability to draw in my wall profiles here, and if you're designing, you know what this dimension is. So based on where you're pulling, oops, you're going to go ahead and you might need this lower section here. Let me go ahead and turn all of these on, my snap toggles. On one of the walls, you're going to need this 10/5 and 11/32. And then on the end profile, if I'm creating the sloped wall, I'm at that 10/6. So depending on how you orient the panel on the inside or the outside of itself, you might need these dimensions to quickly pull. The other thing that oops, I'm going to do a line from here to here. The other thing you can do is you can measure this angle so we know what the slope of our roof is. Down at the bottom, you'll see that's 10.62. So I could just write text. I could place that here. And I could say 10.62. Oops. And I could just say roof pitch. So that way I have the ability to keep that when I want. Last thing is grabbing these walls here. And then, so we've got 9 foot and 10 foot 6. We've got our roof profile drawn. I know that it's a 10.62 angle. Everybody is a little bit different in tiny houses, so it kind of depends, but we'll go ahead and put the driver's side as the high side and the passenger. So right now we'd be looking at a rear section, right? We're looking down this way on the frame. So we know that this tall panel is 10, 5, and 11/30 seconds. So we can go ahead and script some of these items. So the height, 10 foot 5 and 11/30 seconds. And then we'll go ahead and add some openings. You're pretty commonly going to have some clear story windows in tiny houses. So we'll go ahead and put these at 9.6. We'll say that they're 24 inches. That's putting you at a 7.6 sill height. 48 inches is pretty common, 4 to 5 feet. We'll go ahead and offset this a foot off of the end. Now, if you wanted a foot off the end, the one thing that we need to account for is how we lapped that panel. So you could either go offset this in the script and move it manually. That would be 9 3/8. 9 3/8 inches. We don't necessarily have to go through head splits, the different types of header types. A lot of the times you guys will have support from an engineer. Off of that, for now, we'll just do Warren headers. That's usually the quickest. We're not going to split it because it's so close to the top. So you'll see I'll do another window in a second that's a little bit lower. So let's say this one, we'll do a 7-foot header height for speed. They want a 3-foot tall window, and that's going to be 60. We'll do a bigger loft, so we'll do 70. We'll do 6 feet off of the end of the tiny house. Sorry, we'll do 3 by 6. We'll do a 3 by 5 window. 72 inches off the end of the tiny house. We'll go ahead and add one more clear story and call this at a 9'6" header. That's a 2-foot window. 5 feet wide, minus 4, so this will be at 21 foot. And then we can go ahead and see how this looks. Not great, all right? Let's say opening 2, offset, this was supposed to be 72 inches. So this is an example of where you do a head split. I obviously need to redo the offset. Tiny houses, we're often doing 16-inch stud spacing. Opening 3, this will be 19. This will be 19. And a bit more. We need one more foot, 18. You guys got to help me on the math. There's a lot of silence right now. Even more so. 18. Okay. So we've got our little thing, our little tiny house here. This one's 5, this one's 4. Here's a window there. We'll jump to the other wall real quick. And then this one will make that 9 foot. We'll go ahead and add the door. So it'll be a 7-foot door, 7 foot. That's a 0-inch sill height. We'll make it 38.5 inches. And then we'll offset the door 16 feet. So we can go ahead and design this. The other thing too is you can make it your default. That's the one thing that's going to be different with Dev's scripting than ours. So if I wanted everything to be 16-inch centers, or if I wanted all my header heights in a project, on opening 1, if I know that every header height is at 6'10 and a half, when I frame that first opening, I'll make that my default for the whole project based on how many openings are going in. We'll go ahead and do this. We'll pull that back a little bit. And do 14 feet.
And then we get to watch the video and then duplicate.
Well, I wish we were doing a prettier one than that if we were doing that. This one will be 6 feet, Now we'll do 7 feet.
Yeah.
3 feet. Width, we'll do a 5-foot opening again, and we'll offset that 8 feet into the tiny house. All right, we've got a little thing here. Now it's not picking up the deadwood studs. So the other thing is you can script it or you can add it in. We'll see if I think the new software update will automatically add that in. This is where we'll take this 10-6 wall. If you were to lap it the other way, we would need this 10-5 and 11/32 at the 10.62. So this will be a 10-foot 6 wall. Oops, 10-foot 6 wall. 10-foot 6 wall at a negative 10.62 degree pitch. We're going to do that at 16-inch centers. And then we can go ahead and add a window at 8'6". 8'6". And then we'll do it at a foot to match the sill height of that other one. We'll make it 4 feet. We'll offset that 2 feet, and then we'll build that wall. Now, for sheathing purposes, one of the things we'll do is we'll do the sill spacing at 16 inches. And then from an engineering perspective, you could say, decide whether or not you need these jack studs, because if you're doing an entire sheet of plywood all the way across, now for fun, we'll add some K-braces in to this wall. We'll jump over to the tongue. This will be a 9-foot wall at a 10.62 degree pitch at 16-inch centers. We'll go ahead and add that same opening on this side. So we said it was 9 foot. We did a 1 foot opening with 4 feet, offset 2 feet. And we'll go ahead and build this. We got to do the same. And we'll do this, sill spacing at 16 inches. There we go. And then we can add some bracing in. Now, one of the things that we'll also go ahead and do is, actually I'm going to jump to that afterwards so you guys have a little bit more context. So we can take this, and we'll call this wall plan. Make a new plan. I should have gone through the process of creating a project as well. Do you guys know how to do this? So we'll call this OCC test. Job number 1. Okay, revision 1. In our packages as well, we even create cover pages. So we track all of our revision notes on the cover pages. We put our steel specs, the gauges, the profiles that we're going to be rolling, and all of that lives on a quick cover page. So the first thing you're seeing is a summary of the project, not the wall plan. If we're okay with this, we could just go ahead and drop some dimensions if we wanted to for the client. If that size wasn't correct, then we'll call this 200 pixels. That's a bit better. There we go. On this new plan, let's do a loft panel. Let's see, we'll call it a floor panel. So we'll go ahead and do this as, we're going to do it sideways actually, so the load-bearing studs are running from left to right. So we can go ahead and do a 5-foot loft panel. That's running this direction. We want this to be 7 feet off the ground. We'll do the spacing at 16 inches. We'll do the nogging at 4 feet. And then we can go ahead and see how this looks. Now if this was a loft on the right hand side, we might double this end stud over here. If you're rolling on the machine, you can see how sometimes there's direct contact. It's difficult, so sometimes we'll move this over 1/16 of an inch, so it's easier for the guys in the shop to be able to slide this stud through and then wrap around that stud. So that micro fingernail of tolerance makes quite a bit of difference when you're jumping through the assembly portion. We've got that loft plan. And then we can go ahead and copy that wall plan again. And then we can design the roof. Let's see, roof panel. Properties, so we know that this is a 10.62. That starts 9 feet off the ground. And we go to main, we'll want 16-inch stud spacing. We'll do 4-foot nogging for your sheathing. Oh, we said we're doing a 6-inch roof panel, or 6-inch overhang. So I'm going to offset this by 6 inches. Now this is another thing where we'll need one more dimension. So we'll do the same thing, draw that roof panel with 6 inches of overhang. And then I might potentially need this dimension here. So it's 8'11" off of the ground. 10.62 degree pitch. 8'11" off the ground, 16-inch stud spacing, 4-foot nogging. Let's go ahead and see how that looks. Now what we'll typically do is offset, let me see. So that's because spacing, fill type, extra stud offsets, nope, framing references. Oh, 1, 4, and 9/16. So we can offset these 6 inches. So we'll typically create a stud that is aligned with the outside face. Offset. And this gives the guys something to do to align with their hands. So that way they're not trying to guess where 6 inches of overhang is throughout the entire project. They can just line it with their hands and make sure that it's in place.
Or small structures you can put together without a tape measure. So we use the nogging, a little piece of steel, and double it so that you can do it right with the perfect square.
So we drew this. Exactly. So we drew this loft at a 7-foot offset, so I might jump back into here, and then I can offset the bottom track 7 feet. And it gives the guys, again, a guide stud. So we can just change this into, oops, a nog.
So they just literally line it up.
And they line it up, and that's on the left side too. So if we wanted to switch this, I'm going to do a couple of things. One thing I'm going to do is switch the 16 inches absolute. 16 inches. This is also one. Well, we'll split this at an 8-inch header. And then we're going to switch this to 16 inches. Now the other thing that I noticed is this wall sits on the inside of the other wall. So I'm going to jump back and I'm going to go to the stud reference. I'm going to edit this and it's going to be a -3 5/8. That's because the other wall is sitting inside.
Wow.
And
So you're
for
measuring
openings 2.
from the 0 datum of the full 24.
So it lines up, including the 3 5/8. So if it's a 24-foot tiny house, it should be 3 sheets of sheathing from the outside corner without any issue. So now we should have a continuous 16 inches, except for opening 3. 16 inches. There we go. We can add some bracing in here. Looks okay. This one looks okay. The other thing I'm going to do really fast is we're going to go set these nog heights. So we've got 4 foot, and we're going to add one more at 8 foot in all of these projects on it for sheathing. If we were doing a 2-inch drop, which is pretty common on a tiny house, you'll drop the sheathing past the subfloor threshold, then we'd change that to 310 and 710. Does that make sense to everybody? Ish. Yeah, so
We know.
We just want to make sure you know that it's the same thing.
I'm going to go ahead and get rid of this stuff real fast. So if you had a tiny house trailer with a 6-inch main frame that came out, oops, I'm actually going to do one more thing. You'll have 3/4 inch subfloor on top of a trailer, and then you'll have 6-inch trailer base, right? And then you can create layers and codes to put patterns and stuff into all of this. This is why our templates are key. But you would then drop your sheathing. So if this was 1/2-inch sheathing along the outside, we use 1-inch sheathing, so it's R3 zip. Then we might potentially bring the sheathing down 2 inches, like this, so that water can't get into that threshold right there. So if you offset this by 4 feet, this would mean that the center line of your next sheet of sheathing is actually at 310, not 4 foot. Good? So this one we went ahead and fixed. This should be 16-inch centers. We got our bracing in, 16-inch centers. We got our bracing in. This is 16, but we didn't account for that half step. So we're going to go ahead into our stud references again. We're going to edit this to be -3, oops, and 5/8 inches. Okay. I don't like nog pass-throughs personally. They are the worst to assemble in the shop. That's that nog passing through that header. It's terrible. Please don't design nogging going through your header, so I'm going to turn that off.
So do you do staggered?
Yeah.
Look at that.
And this looks a lot normal to what a residential framing inspector would see. If this was just like an 8-inch header on top, we'll go ahead and do this to, right? That looks like a header. That's what you would see in steel. Sometimes if this was a massive opening, what we'll do on opening 2 as an example, opening 1, I'm going to make this 5 foot to match the other side. We're going to go to opening 2. I'm going to move this over a little bit. And then we're going to go down. We're not going to allow nog pass-throughs. One of the other things is you can turn off these jack studs or the extra studs. Let's say I don't want jack studs, but if this was a 10-foot opening or something that was relatively large, what I would do is I would mirror the studs here. I'm just going to delete this, mirror this stud, and then you could trim extend these to go into this and into this. I could go ahead and draw a plate. Oops. I could go ahead and draw a plate right here. I'm going to pull this back, and then I'll flip this the other way. Right? So you almost have a header. Oops. Trying to extend. And then we could flip this that way, and then flip. We could break this header right here, and then flip the top section of the stud this direction. So this header could ship as its own panel. Do you guys understand that? So I would go to member break, I'd click that there, I'd pull this one up to here, like that. I'd pull this one to here. This one is the smooth side of your window, and now you have the smooth side screwing into the screws. Both of the webs are touching, so now you could take a drill and you could drill this header in separately. So if you guys are shipping massive headers, you have the ability to now add a new panel break location. You could do the same thing with the jack, with the sill. All right, so you could pull this back, and you could turn this into its own panel, right? And then the guys could screw that in on site.
Real quick, what's a plate?
So the bottom plates, if we were to break this bottom plate here, and we were to have these panels as two separate ones, and then we broke this here, and then this goes, we'll flip this, so the webbing is so the two smooth sides are touching, and you can get drills through them. And then I'll go ahead and pull this bottom plate over to there. And now this sill can ship independently. This header can ship independently, and the panel is now here, an individual header. So this is where uploading the elevations and showing people like, oh, this is a header floating up in space. If we're shipping 60, 80 panels on a 2,000 square foot house, it helps it break these into more manageable pieces, especially if you're working on multiple, level structures. So you can see the smooth side of the webbing. You have the smooth side of the window on the outside. That's making contact again, web to web. So you guys can see how these top plates are separated. This is two smooth webs making contact. So this panel is an independent panel that is now sitting on a seat. So if you're working with big, massive openings, engineers, instead of relying on the strength of this screw and this webbing that would tear out, you're now relying on something that's sitting.
So that PL1 is actually like kind of a top plate that the header sits on top of.
And I can go ahead and grab it for you guys.
Yeah, we make a lot of bean box, a lot of truss seats, so that, again, sort of nobody needs it. All they have to do is use their hands. If it's flush, it's square.
See that? This is its own panel that we could ship with smooth sides around the entire outside face.
Nice.
Oops.
It's like a 2 million lift.
Yep.
So going back to what you were saying about what we
Can everybody see that?
Yeah.
And that's how those walls come together.
where you're
So you can, it's another tool to add to your arsenal for shipping logistics and like getting these panels out, because nobody wants to lift a 500-pound panel with their buddy on the other end. Like, yeah, it's not fun at all.
How do you adjust for this for roofs?
Roof panels are going to be the same. So we'll go ahead and you can run checks and balances in the software. So if you were to go ahead and set max frame sizing and frame weights for yourself, you can run checks. I still run analog checks all the time. It also doesn't it's not perfect, but if you say I want my max panel size to be 8 feet by 12 feet, and anything that exceeds that, it'll show up in this oversized max frame size. So it's saying it's too big, it's too big. All right? And if you were to look at this panel here, we're at, 400 pounds, 380 pounds. So if your client's maximum weight was 150 pounds, you could plug in 150 pounds and run that check to see any panel that's over 150 pounds, and we'll typically put oversized panel in the production drawings. We'll put that up at the top so the client or the guy receiving that knows, like, hey, so just so you're aware, there's 2 panels that exceed your shipping requirements, and that's notated in the drawings. This thing's probably a little bit of a mess. So roof panels, same thing. If this was a 10-foot panel, I know that we'll probably break them at 8 feet. So I'm going to go ahead and grab the one at 8, the one at 16, and then there would technically be one more break if we didn't have overhang at 32. But I'll move this over 13/16. That's half of a stud width, and then I can go ahead and mirror these. Oops, I think that was the right one. No. 8, 16, 7. It's this one. And then you can go ahead and break all of these studs. All right, and this just became an independent panel. All right, same thing. You can do the same thing with the walls. So if we knew that we wanted to break this into 8-foot sections, I might have my first 8 here. The other thing we're missing in this is service holes. So stud references, service hole references. We'll go ahead. We're typically doing 18 inches as our first, because hold downs are usually 12 or 18 inches. So if you have a 12-inch hold down, you want to make sure your first run of electrical cables is above that, so that you're not missing an entire run, have to go up, over, and around the hold down. So we'll typically do 18. I'm going to edit this one, and we could do 32 inches, right? And then we could do 3'6" 1'6", 3'6". I'm going to do 7'6" instead. 6 inches, and then we can go ahead and do 9'6". I would make this my default in the beginning so it's consistent on every single panel that you draw across the entirety of the project. What's going on?
Service holes are important when you're assembling because they actually.
There we go.
That holds off a little bit. So everything, when you come to shoot for guys in the field, when they're assembling, because when you're breaking a lot of panels, you have there's a lot more to ensure that. And the mistake that people will make, something they would be a screw underneath the panel, would do something, would be in the air, those service holes not lining up with the way that the machine's gonna be right. You know it's off.
There's, with our machines, we run Howick, and we're able to put web holes.
Mhm.
It has like 3 holes, so when you line up, they line up perfectly, and they're already pre-drilled, so it's like,
It's so much. You can use it as a tool, absolutely. So we talked about that. Let's see how this thing looks. No worries.
I do a lot of things.
I think it made it to the desktop now.
Oh no, go back to Detailer and just go File, open 3D. Yeah, it should be on the desktop.
Desktop. It's going to be OCC test.
all the way up to FrameCAD, the very top, the top left folder, yep.
I was on the desktop. There we go. We added that little reference guide on the end. The only thing that's off is these stud references here. Service holes in the roof.
And shouldn't the truss, the roof go straight down to the side?
Yeah. So what we'll do, let me see, 1 foot 4.5. So we're going to lose some of that, but we can go back and we have stud spacing at 16 inches. Spacing type. This needs to be absolute. We're going to go ahead and rebuild this. So now that should be at 16-inch centers, but remember what we did is we have 6 inches of overhang. So I'm going to go ahead and move this over 6 inches, offset. There we go. So now we've got deadwood studs on the roof, right, along the interior. It looks like, sorry, so the only thing we would still go do is we have that one that's aligned at 14, and then I'd go ahead and offset this 3 5/8. Oops. 3 5/8 inches on these two here. There we go. Got a little tiny house. Got the deadwood studs.
Nice.
All right, deadwood studs here. There we go. All right. A little messy. I know that there was a lot of growth and perspective that we picked up that I tried throwing into a single demo. The biggest thing that we encourage our clients to do, if they have DXF files, you can import DXF files, right? And you can bring those into lines, and then you could grab, this, and then you can move this into a DXF layer, or you can move it into your manual import layer. You can add your own layers that have different color codings associated with them. So if you wanted all of your lines to be red, then we could go ahead and drop in, the true dimension plan into this. And that way, the other thing you could do is when you're coding walls and windows, you could go into this tab, and if we wanted to do, let me see, I'm just going to redo 2. You could say pick feature from the plan, and then if you have little window ticks, let's just say we wanted the window here to here, it just did that for us, right? Pretty easily. So you can go ahead and pick your offsets very quickly off of doing that. We're missing, we've got the deadwood. If we wanted to, again, add a space for that loft, a little nogging for that loft there, and that came to the edge of this window. We might do it.
When you're using it just for a dimension, you don't need the whole knob. Sometimes you just need one. You just need one little piece of steel. You're trying to get light enough to steel. You don't have to put the whole knob. You can just keep that guy. So you don't have to. We're always trying to go out to steel. Sell steel. So you guys are shipping it too.
Correct.
Our smaller houses will work to try to go to 150 pounds. So you can look at that.
Offset 7 feet.
Cuts down, makes it safer job site, it makes it easier for everyone us to move them around. When you're getting it finished, that's easy. What you have to actually do is get it out of the machine without jamming. Make sure, because you design stuff in here that the guys can't put together. What they'll do
Yeah.
We're sending out, that's our finished product in a lot of cases. So we're not sending out finished panels, but that's inside. It doesn't matter if you crinkle the stud and we hit it with a hammer, but it does if someone's wanting something really shiny and they bought something perfect and they love this thing, so it needs to show up looking like it did when it came out of the machine.
But this just means the guys don't need to pull out a tape measure. They can just sew up, you know, if we're looking at this piece here, you know, especially if we're doing a really large project and material is a consideration, which it always is, we might just go ahead and do this here, right?
How small of a reference data might you make?
And then we could do the other one there.
It's just to line it up.
Mm-hmm. And then,
Pretty hard to mess that up. Steel, you can't be off, you can't bend the panel out of whack. As long as you get that, flush that out, it's going to be.
so that might be like that. Now, the only other thing that we could talk through is if we were to break this panel, how would I break this panel? So that's at 7, 8 3/8. So I might grab this stud and this stud at 16. I'm going to move them over 13/16 of an inch. That's so my sheathing still lands on a full stud at those panel breaks. Might grab that one too. And then you can go into the plan and you can do frame break. And I'll break those at that point. And then if that was EX1, I'll typically go in and I'll do EX1 dash. I'll go into this one and I'll do 1 dash, and now it's 2. And EX1 dash 3. All right. And now same thing. This panel is just under 8. All right. Yep. Just a little gap in between them. And now you have panels that you're moving around that are 130 pounds, not that 360 that we were originally looking at in the very beginning. So a little bit easier. The only thing we were missing was these horizontal and vertical service holes. I'm not going to reset the values, but make sure you guys put service holes in the framing for sure. We'll stop these short so they don't go through the header. The other thing is you can draw service routes and route things up and over openings. So if we knew that there was nothing, you know, if our service hole run on our other wall, this one isn't a very good example, but we probably wouldn't run the service holes through the header this close to the bottom of the webbing because it removes quite a bit of material. If we're running it through one of these ones that we could go up and over on a head split, which would have been like this window, then we might just, because there's no horizontal service studs, so might just have that there. Oops, wrong tool.
What was that for?
We were doing a left flange notch.
Gotcha.
Yeah. Huh. Let me see. Oh. There's new updates all the time, guys, and I haven't been on this in like 3 or 4 years, so apologies for the slowness and sloppiness.
Like, no.
But yeah, I mean, you can see all of our nogging is around the entire project, right? We would have added that 8-foot nogging here, so they have multiple levels. You got that 4-foot nog, you got all your deadwood studs, here's that guide, so you can see it catches the end. So if you had, 2 guys working on this project, you could line up with that back wall and that side wall at the same time, and that speeds up assembly and it makes it perfect so the guys aren't pulling out a tape measure and having to align it. They're relying on the machine accuracy. Same thing with the overhang. If this was 18 inches down a 100-foot elevation of a house, it's really easy for that 18 inches to get seasick and wave in and out if you're pulling a tape every 4 or 8 feet. Our guys just have to take their fingers and align it with the outside face, and then they'll take a screw and go up through the bottom or through that flange through the top. So it's not the prettiest tiny house I've drawn, but it's a tiny house.
But when you bring that up too, Matt, that 5 extra minutes you spent designing it saves a lot of time and labor because everyone was
Yeah.
sitting there.
I had the pleasure of taking the machine apart every time there was a jam. I've had the pleasure of assembling tiny houses and residential structures.
So that's why you're saying doing your own drafting saves all the headaches, a lot of the headaches, because you know what your machine's capable of doing.
I think Mark would probably say I'm a bit of an anomaly. It's really difficult to get that type of experience unless you've been on the bad end of a phone call before.
It's a startup mentality as well. This is when we had a machine problem, because we were early, Jayson probably still remembers the circuits that we had to pull apart to actually go get to be on with New Zealand all night and to figure out how to get, not just our guys can, field strip the top of the machine really quick if we do get a jam. That's second nature. So you want to really want to design out those jams, but being able to kind of do the stuff underneath, the bit that you pay all the money for the machine is down below.
Mm-hmm.
Hard stuff breaking, I've got no paperweights on the desk, thousands of dollars for the thing to make sure that everything's locked in. So yeah, he's done from starting to, probably the first person I ever got. We had to talk him into letting us get a designer seat without actually having a machine. So he was the person to do that. And then we put together some oral frames. The tiny house thing, because it's so challenging, because we forced the machine to do things it was never meant to do. And we were doing, you could build walls, but you probably could design 1,000 square foot house quicker than that, because that's what the software is designed to do. It's really easy, especially when you script that. Like here's what's on his machine, and he literally hasn't done this in a couple of years, so obviously it's a little bit of a brain fog. So all his free time he could be helping us with the designs on. But and the core thing is he didn't do it in 15 minutes, so he got my computer.
I was probably what, 35, 45? Where am I at? 25. Yeah.
He could have easily faked it, but he can't. That's why
I can't. Yeah, it's.
But what this makes us, as getting into the industry, makes us feel a little bit better that there's always refining that needs to be done. And, as we'll get quicker and as we drive this,
There's nothing like trying to put something together on site when if you don't punch the service hole and put the extension of the drill to get it, that's screw it. And we're just like, okay, well, and yeah, you can always work around it. There's always, you can get up the steps, you can cut stuff and put things back, you can pull wood in if you have to. There's lots of ways to fix things in the field. But when the guy, when you get a whole frame where there's no service holes, that's a miserable afternoon or day, drilling out all those holes or something. You really respect what the machine does.
The last 6 months, I've been working on mezzanines and conference centers at that house. So like tenant improvements, and it's all in FrameCAD. And the thing is, we can't get already built walls in the doors, so we end up pulling all the sticks in.
Right.
Stuff gets put together wrong, the surface over on time, because we have to cut them ourselves. So the way you guys do it,
That's the way we started. We do an open manual of the shopping center, figure out. And it's the same, when Jayson put the high side on the driver's side. Well, that's important because when we've ripped roofs off things, we've run into inside probably the Superdome, when Jayson smashed it over the ceiling.
I don't know about that.
They're always hitting freeways. It's the last mile. The freeways easy. We can get all the way across the country. That last mile of the neighborhood, there's tree limbs, there's wires that are down. So that high side and the driver's side, because your bridges, your low bridges, you want the highest part to be a little bit the same as the tree. As you pull into that customer, driveway, that's where you have to be really careful. So it's getting onto the highway, getting off on the highway, all those things. Yeah, we've learned a lot.
and when you guys
experiencing right now, we're putting some root panels together at this moment, and yeah, the weight is astronomical, it's 683 pounds.
Yeah, we start using 18 gauge versus 20, 22, that 18 gauge. Because the other thing about, you gotta remember, get your coils, there's a big range for 18 gauge or 20 gauge. If you get a heavy 20 gauge that feels heavier, you go, why is this, it's as heavy as 18 gauge. You get a heavy 18 gauge, it's really heavy. It's not, when you're buying something by the pound, it makes a difference. You just have, there's variations. The mills are allowed to have a certain tolerance in there. And the mills want to be on the fat side because you pay by the pound. So they're making the fat. We want to be on the thin side. I want the 18 gauge because I want that. That's what gives you your spec. I don't want 17 or, I want 18. I want as close to 19 because we're trying to make it light. We want to make sure that it's structurally sound. But those are sort of working against you a little bit. So you can end up, and you just have the consistency. So every time when that steel comes off and you're measuring it to make sure that it's code compliant, all the things you can do to make sure that that's actually going to comply with your ESR or ICC certifications. So you're running that 1 foot stud on every project to make sure it's exactly 12 inches, you're doing all those sorts of things. Yeah, to make sure that you're, and that's why you buy FrameCAD. FrameCAD Scottsdale or Howard, because they're the ones you can put 1 million feet of steel through and still have the same tolerance. We work with the tariff where they went back to doing about 9 projects for somebody Polish, and they never, the machines after they never bought cheap machines. They had a couple FrameCAD actually developed ones, and they bought some cheap machines, they never got them valid. And the machine that you don't have the tolerance on is useless, and there's lots of them. Yeah, you guys are working with, we like FrameCAD. We started now, we don't use Howard for our like compact, footprint. But it's the, well, we like it as sort of the Apple model where we start with Howard and we have a problem and we call and the software guys would say it's a hardware, the hardware guys would say it's a software. FrameCAD was the Mac world where it's like, okay, it's bespoke, so it's all. Now they're going to more of the Howard where they're going to allow people to use, open source. We're machine agnostic, we don't care what we're rolling. We're rolling another, hopefully if we need to do 1,000 houses for, fires, we want steel coming from every corner of the country. That's one thing, this scales. You can't bring in all the carpenters you want, you're not going to be able to kind of actually have the tolerance and things just coming from. There's lots of guys that have machines, they thought they were going to print money, and they're just sitting there idle. So we can call those guys up and go, yeah, here's the file.
How long would this take to roll out the machine?
To roll? Jayson, that 5 hours, 6 hours?
6,000, like 6,
9,000 pounds a day.
yeah, it's about 10,000 pounds a day, so, I mean, probably 3 hours or less. Depends how many,
How you guys actually using when you're spinning it out?
Great question. So what's actually most important is understanding as things are coming out for production when you export it, it's knowing what the length of stud is. So as it's coming out of the machine, if you guys remember, it'll start with, stud 1, bottom plate, then the bracing, then the nogging, then the second brace, then that, and then the top track. If it got through that and then I saw that following these studs, we had all of these little webs coming out, and then some braces with a lot of webbing that was getting removed, especially if you're doing like an 8-foot truss or a header. We'll slow the machine down because as you're removing webbing material, you have an increased chance of creating slip or it crinkling off of all of those web cuts and web notches. So we'll typically run anything from the 5% or the slowest setting on the machine to about 85, 90% if we're printing. Yeah. It's 80%, 85% is about as fast as it goes. So if you're doing like heavier 18 gauge studs and you're just doing 14-foot studs out of the 6-inch machine over and over again, you can let that thing crank absurdly fast.
Jayson has to, the designer has to design it right, and the guy that's running the machine has to know that, okay, I'm going to dial it down, speed it up when I can, dial it down. And that's how you prevent that jam. Instead of taking 20 minutes to field strip the machine, you keep going.
Because if you could see all of the material that's being removed out of this brace, that's a vulnerable point for production. So the first thing out of the machine is stud 1, and then brace 2, and then as it's, finishing stud 1, the machine's about 12 feet long, so we'll slow that down to like 15-20%, let these braces get out. We could speed it back up as it starts printing top plate, stud 2, and then next thing that'll come out is this jack stud, and that sill. Then as the sill is coming out, we'll know that this header is next, and then it'll start tackling those smaller pieces, so we might slow it back down to 15% as it comes out of the machine, and then jack stud 2 is coming out of the machine, and then we might speed it back up, and then we'll slow it back down as these last 3 headers come out, and then we might speed it back up as these longer studs start coming out of the machine.
Do you think they'll ever make a software you can program that in there?
It's really, really intelligent as it stands, the way that it produces the order. We can do manual export in the software as well, but I think the automated one is as good as it gets.
I mean, the speeds.
I don't think so, because that's also a tailored, it varies on gauges. When you're doing these small compact designs, there's exponentially more complexity involved with the tooling on the machine than you would do on a 10,000 square foot commercial job. It's really hard for them to understand all of the little nuances that we've picked up. I'm sure FrameCAD knows what some of those pain points, so the guys that are in New Zealand that have been doing this for 15 years plus probably know when they slow it down and when they speed it up. I don't know if the software will ever be at a point where it understands those micro nuances on production. Not yet, or at least not to my knowledge they're doing that stuff yet. I know that they're working on, what's the new software we were just talking in Vegas about, where they're doing the panel order, they're helping you stack it, ship it. It's Nexus. Yeah, Nexus. So
That's the one that's moving away from detail, right? So implementing that.
So we've taken like a handful of the components of that and created our own. So we create our own shipping list. We take the Excel spreadsheet, we created our own Excel spreadsheet that takes that, we go into a label maker, and then we put QR codes with the weight and with the panel size and the panel ID. It does shipping list.
Everyone's candidate, so we know where you're at.
100, yeah, exactly. We do an opening list, so it'll, the Excel exports all of the openings, and we can do a rough opening checklist, so our clients can sign off on all the rough openings in a single page.
You have to write it yourself to build a little formula to take the gibberish that comes out of the Excel sheet, so because a customer can't look at something .368 and say, yeah, that's the size of my windows. You have to convert that over for them. So there's a whole bunch of steps that we don't need to know to build it. But the customer needs to know the windows.
So when someone sends an order in, do you guys have the foil in stock, or do you buy metal once the order has been
No,
placed?
you need to have steel on the floor.
Always on the floor.
So you guys have.
And then the supply houses can also hold those master coils. So if you're
Slit for your 6-inch machine, or 3 5/8, or your 3.5 inch. So they'll hold it. You pay for your slitter to hold it.
Right. So do you guys get more than? Oh, I'm so sorry. Do you get more than one cut off the mother coil, or do you provide just one size?
It'll be for the machine profile, and if we know that we're doing a 5,000 square foot house that requires 1,000 square feet of a 4-inch strap, we can have the slitter cut us 4-inch strapping using our 20 gauge material. But that way, if we have these master coils of 18 gauge or 20 gauge, and we don't know whether the next projects that we're going to be producing are on a 3 5/8 or a 6, the coil is the same. So we just, if we are doing a 30 or 50,000 pound multifamily project, and that's going to be 18 gauge, then we're going to go get ready to have that slit. It takes a lot less time to have it slit and dropped off at the door than it takes to order it from the mill and order those master coils. So it's typically ordering a quarter ahead of time, and then we'll have those master coils, at a shop in Texas versus off on the East Coast, which is where we source most of our steel. and then you're slitting it, which only is a matter of weeks, 2 to 3 weeks. So as we're going through the engineering process, if it looks like 15,000 pounds of that is going to be 6-inch and 18 gauge, then we might go slit those coils ahead of time and have them ready, and then leave the rest of the master coil down the road, whether maybe the next project is 3 5/8 18 gauge. But that way we're not having 6-inch 18 gauge coils sit on our floor for 8 months because the next project we needed was a 3.5 18 gauge profile. All right, here's this rudimentary tiny house. How much does it cost, or how much would we charge somebody for it?
How much would you charge somebody?
We would most likely charge somewhere between $5,500 to $7,500.
And that's just for steel and trailer.
That's just for the steel, no trailer.
Oh, that goes with the trailer? Oh, okay.
No.
And
Is that including your design cost?
Hmm?
Is that including your design cost, like the time to actually model?
So we're charging to design tiny houses $750 for any projects under 750 square feet. So you can see it took me about 30 minutes to design this. It's not a very good example because this thing's a bit of a mess at the moment. We do a lot more, but it's anywhere from, we're probably averaging 6 hours, including revision time, on a tiny house design under 750 square feet. So that's kind of our barrier to entry, and then we charge $1 per square foot for frame design on anything larger than that. So if it's a 2,000 square foot house, we charge $2,000 for FrameCAD design and detailing. Engineering is a separate fee. So our engineer is anywhere from, $1,500, $1,800 all the way up to $5,000, depending on the complexity of the design, load requirements, where it's going. Are they doing foundation, framing only, or framing and foundation?
Do you have in-house, or do you just have consultants that you work with often?
2 engineers, one of our engineers has a license in 48 states. We've also shipped stuff internationally, so there's quite a few things to take into consideration on that front. And then we have another guy in LA that also will stamp some stuff out here. His background is more big, massive, multifamily and commercial. Actually, I guess they both do that. One of our engineers is really good at incorporating structural steel and HSS with the sheathing, with the strapping, with other structural components involved. And we're advocates of FrameCAD, but one of the limitations of the FrameCAD structure software is you can't incorporate third-party materials outside of the steel to make sure you're exceeding local load requirements. So whether that's RISA or some of the other different structural engineering software that's used, we find that our engineers are taking some of the basic rudimentary math that structure comes, but if we need to account for 1/2-inch sheathing on the outside of that frame, then they might have to remodel certain sections of wall and then use third-party Simpson strapping or structural sheathing and get shear wall calculations off of that. We've done enough projects now where we have a pretty big catalog of structural connection details that we're just recycling at this point. We've got floor joist tables, roof joist tables. We've got span tables for our 2x4 at 24-inch centers, 16-inch centers, 12-inch centers. So our drafting team has all of the tools that they need to know when we have to up the gauge, up the steel profile. We already kind of know what depth of trusses are required at various spans. So by the time we're getting it to our engineer, it's just it's a stamp. Yeah, we're almost never changing the frame design at this point. I think the engineering is important and having a relationship. I think what I loosely scattered through today is these little details of, it's really important while you're early adopters of a new design software that you could potentially take into the real world and make a profit off of. It's ensuring that everybody who touches this has a fantastic experience. When we got started 10, 12 years ago, if, as a startup, you want everybody to be able to put this thing up with ease, and then you want to make sure that the contractor is also happy throughout the project, because if the contractor is complaining the entire time, they end up with a bad taste in your mouth, even though you delivered what you're supposed to deliver. It was a pain in the butt for everybody else involved in the project. But I hope that was helpful for you guys-ish a little bit.
Like if you were sitting in front of your own computer with your own templates and not trying to teach a class, you would have done it in 15 minutes.
I think if I knew what the default selections were and my service holes were all punched, I think 15 minutes for sure, because I've done it for sure. But even if though it was loose, I think we ended up there, right? We've got all of our nogging in place. We've got guides for the loft in there. We've got all of our deadwood studs.
Probably gonna think of something to drive back.
I know, this thing is messy. And it's being recorded too, so now the whole world thinks that I, have no idea what I'm doing, which is mostly true. But I think the whole point is you can figure it out. It's not going to be perfect on your first export either. Like even myself, I'll look at things and I'll think like we'll start with preliminary drafting, and then we have to go think through, okay, how are we breaking this? And then after everything's broken, okay, how is the team putting it together? Is that cavity too small to get an impact drill? Do I have to reorient the way, if this window was too close, if I knew that you couldn't, we need at least 9 inches, so if I knew that this was closer than 9 inches, well, maybe I restack the order of the end wall and the side wall to be able to drill it from this side because you have 16 inches on this other elevation.
We've never done something that we put together, and after we put it together, we haven't gone back and made one tweak to make it better. Or to go and make that experience, just to kind of, because, when you put your hands on it, you actually do it. The nice thing about the repetition is that, it's in your best interest to go back and fix that for the next guy.
Mm-hmm.
And even, we do a lot of retail stuff in the other businesses, and that's what, as much as they think that's their new concept, they got to go 3 times before then you're not making changes. You just have to do things over because no matter how much you think it, it's still, doing an angle or rail out there. It's going to be a little bit different than
Here we go. I just changed the header because I know that those were on 24-inch centers and not 16. So theoretically now, I would maybe think about sending this out to the machine at this point.
See, I didn't even know you could refresh while you're in this viewer.
Control F5, and then Control 7 throws it. Yeah, so if you don't close
So it's like the
SAP.
when we do it in Structure.
And then Control 7 just turns on my profile line so you can kind of see the ends of it a little bit more. You can get fancy and do section cuts. So sometimes we'll go through a whole project and we'll just go see, is this line, is this stud actually, truly aligned, right?
Yeah.
And then
one of the nice things about Sketchfab is we can actually drop into Sketchfab pretty quickly. We can put it on the VR, and the customer walk around and go, oh yeah, I see what you're saying about the window. Let's move it.
early days we used to load big projects into the Oculus because you could walk around in the shop and see in real life, can I actually get my drill in there? Are we actually going to have access to get these panels fastened together? But that was messy, but I don't know, I hope there was some value passed on there, right?